You ever heard of a law so important it literally broke the numbering system of physics? Well, that's exactly what we're diving into today. We're going to unpack the strange and totally essential story of the Zeroth Law of Thermodynamics.
I mean, right off the bat, you've got to ask yourself, in a world full of firsts, seconds, and thirds, how in the world do you end up with a zeroth law? Seriously, it sounds like a bug in the code of the universe, right? But believe it or not, it's actually one of the most logical things in all of science. And here's why. It wasn't some kind of afterthought or a simple mistake. No, it turns out this zeroth law is so foundational, so absolutely essential to everything that comes after it, that physicists had to go back and basically rewrite the beginning of the book. They had to place it right at the start. So, to really get why this happened, we've got to do a little time traveling. Let's rewind the clock. Because, and this is the key part, the story of thermodynamics, well, it wasn't written in order.
Okay, so picture this, the first and second laws, the big ones about energy conservation and how heat flows, they were already the rock stars of physics, the pillars of the field. But then, in the 1930s, this physicist, Ralph H. Fowler, comes along and points out a principle that's so basic, so fundamental, that everyone had just been, taking it for granted. And he's got a problem, right? He can't just go and renumber the famous first and second laws. So he does the only logical thing you can do. He calls it the zeroth law, because it just had to come before everything else.
So what is this super important law that caused all this trouble? Well, when you first hear it, it's going to sound almost ridiculously obvious. Like, that's it? But trust me, you have to stick with me on this, because its simplicity is exactly what makes it so incredibly powerful.
Okay, here it is, in all its official scientific glory. Now, the phrase you really need to lock onto here is thermal equilibrium. That's it. That's the heart and soul of this whole thing.
Let's break this down. It's actually super simple. Think of it like this. If A is friends with C, and B is also friends with C, then guess what? A and B are basically friends with each other, even if they've never met. In physics terms, if system A has the same temperature as system C, and system B times also has the same temperature as C, well then A and B must have the same temperature. That's it. It's called the transitive property, and it's this simple little rule that makes temperature a reliable, measurable thing in the first place. So what exactly is this thermal equilibrium? It's not just a vague idea, it's a very precise state of being. When two things are in thermal equilibrium, it means they've totally balanced out. All the action is over. No more heat is flowing from one to the other because they've reached the exact same temperature. You could almost call it a state of thermal peace. Everything is calm. And this brings up something that trips a lot of people up. It's super important to remember. Heat and temperature are not the same thing. Not at all. Heat is the energy itself, the stuff that's actually moving between objects. Temperature is just the measurement. It's like the scoreboard for that energy. And the zeroth law? It's the rule book that makes sure that scoreboard is fair and consistent for everyone.
Okay, I can hear you thinking, so what? Why does this even matter? Well, get this. This ridiculously simple, obvious law is the entire reason a tool you probably use every single day even works.
Yep, that's right. I'm talking about a thermometer. Every single time you check the weather, or check if your oven is hot enough, or take your temperature when you're feeling sick, you are putting your trust completely in the Zeroth Law of Thermodynamics. It's the secret ingredient that makes it all possible. So let's actually walk through this. Imagine your system A. Over there is a pot of boiling water. That's system B. Now, you want to know its temperature, but you can't just stick your hand in it, right? So what do? You grab a thermometer, our trusty system C. You put the thermometer in the water and wait. When that reading stops moving, it's because the thermometer, C, has reached thermal equilibrium with the water, B. And because of our zeroth law, you can now trust that the number you're reading on that thermometer is the exact same temperature as the water. The thermometer acts as the perfect, reliable go-between.
And that right there is why Fowler knew this law had to come first. It's not just some neat trick for how thermometers work. It's about the very concept that holds up the entire field of thermal physics.
I mean, think about it. Without the zeroth law, the whole idea of temperature would just be a chaotic mess. It would be inconsistent, totally unreliable. We wouldn't have universal scales like Celsius or Fahrenheit. And those other big laws of thermodynamics, the ones that depend on having a solid definition of temperature, they just crumble. They wouldn't work.
So you can really see the hierarchy here. The zeroth law is the foundation. It's the concrete slab that everything else is built on because it defines temperature. All the other laws, the first, the second, the third, they're the walls and the roof, and they all need that solid, reliable foundation just to stand up. You could say the zeroth law is the boss.
And here's the cool part. Once you really get this, you'll start seeing this principle in action literally everywhere. It's one of those things that once you see it, you can't unsee it. It's quietly shaping our world all the time.
Just think about it for a second. When you cook something, your oven works by creating a state of thermal equilibrium with your food. That's the goal. Your air conditioner? The thermostat is constantly acting like that system C, checking the room's temperature to keep everything in balance. A doctor taking your temperature? Pure zeroth law. Heck, even something as simple as leaving your phone on your desk. Eventually, your phone, the desk, the chair, they all reach the same temperature as the room. That, right there, is the zeroth law at work.
And that quote really just nails it, doesn't it? It might not have the fame of the first or second law, but the zeroth law is truly the bedrock. It's the logical key that unlocks our ability to measure and understand one of the most fundamental properties of the entire universe: temperature.
So when you boil it all down, the zeroth law isn't just some quirky piece of trivia. It's a really profound statement about how we can agree on a shared reality. It gives us a consistent, objective truth about temperature. And that leaves me with one last thought for you to chew on. What other fundamental, often overlooked zeroth laws are out there? You know, the basic unspoken rules that create the foundation, not just for our science, but for our world, and maybe even for our own lives?